Guys, so we're on page 127 of your student journal, solving systems of linear equations by substitution, section 5.2. One thing you should notice that we are doing the same thing, solving systems of linear equation, but what's different by substitution. So we're just going to be using these different methods to do the same thing to find the point of intersection between two lines. So with that being said, let us go ahead and move forward. Solution of a system. Just as a reminder, I didn't go over this formally in the last video, but I will here. Solution of a system of linear equations where two lines intersect, or the point of intersection between two lines. Okay, moving on. Solve one of the equations for one of the variables. Substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the value from step 2 into one of the original equations and solve. This sounds like a mouthful if you haven't done it yet, but when we do it, you'll just refer back to these steps and you'll see that it is actually pretty self-explanatory and makes a lot of sense when you know what it's referring to. So first, solve one of the equations for one of the variables. Let's just go into some examples now. Because y is already by itself, this one is already solved for y. So let's go into the step 2. Substitute from the expression from step 1 into the other equation. So because I know that y is equal to 5 plus x, that means anytime I see a y, I can replace it with this. Why can I do that? Because they're equal. If they're equal, then that means they're the same thing. So I'll say 2x plus 2, but instead of y, now I will say 5 plus x. So I got 2x plus 10 plus 2x equals 10. Now notice nothing has happened over here because there's no y to substitute. 2x plus 2x combine like terms. 4x plus 10 equals 10. Get x by itself. Subtract 10, subtract 10. 4x equals 0. Divide both sides by 4. X equals 0. And the last thing is to substitute. So I know x equals 0, and I could just go back in here or here and plug in 0. It's entirely up to you. I'm going to change it back to blue because it's a much nicer color to me. 2 times 0 plus 2y equals 10. 2 times 0 is nothing, so that's just 0. Positive 2y equals 10. So how to get y by itself? I've got to divide by 2. Y equals 5. And my solution is, my x comes first, so 0. And then my y is 5. 0, 5. Now it says check your solutions. So, and remember, when we have a solution, it doesn't have to work for just one of them, but it has to work for both of them. So 0, 5. 2 times 0 is 0, plus 2 times 5 is 10. 10 equals 10. That's fair. Y equals 5 plus x. So we say 5 equals 5 plus 0. That also checks out. 5 equals 5. So our solution is 0, 5. And we checked it and it works. Next, 2. Now here, x is already by itself. So I'll say, instead of x now, I'm going to take it, and instead of x, I'm going to replace it with all this mumbo jumbo because they're equal. So negative 2y minus 1 minus y equals 3. 2 times negative 2y, negative 4, negative 4y. 2 times negative 1, negative 2, minus y equals 3. Negative 4y minus y is negative 5y. Minus 2 equals 3. And you add 2, and you actually end up getting y equals negative 1. So now what I can do is, in the last problem, well, I can't remember which one I did, so say x equals, instead of y, I'm going to replace it with negative 1. Negative 2 times negative 1 minus 1. So 2 times negative 1 is positive 2. 2 minus 1 is 1. So I will leave it to you guys to check because, well, for the sake of the speed of the video, you guys know how to check. You just plug it back in or substitute. So go ahead and do that. X equals y. So here I'm going to show you two different ways. So x equals y and y also equals x. So instead of x, I can replace this with a y. I can say y minus 3y equals negative 1. But since y is equal to x, I could also say x minus 3x equals negative 1. Okay, so we have, let's see here, y minus 3y is negative 2y equals negative 1. Divide by negative 2, y equals 0.5 or 1/2. I should say 0.5 because some of you guys won't see that point. Negative 2x equals negative half, or sorry, negative 1. But I gotta divide both sides by negative 2. Let me redo that. So negative 2x equals negative 1. Divide everything by negative 2. X equals 0.5 or 1/2. So before that's pretty much it. So it goes for all these problems, and you just do the same thing. You substitute, and you work it out. And all these are solved for. This one's really simple. I know it only has a number, so you just have to go like this. So you solve this for x. 2x minus 12 equals 0. And you already know no matter what you get for x, your y is equal to 4. So it means this is the first thing I can put in there. And then you find x. Okay. Okay, so that's that section. Here, it gets a little bit harder at number 10 because nothing is by itself. So here's what I will do. I will make y by itself. So again, going back to step 1, it says to solve either of the equations for a variable. Here I'm choosing to solve for y. So I'll say 2x plus 4 times, let's see, 3 minus x equals 8. 2x plus 12. I'm distributing this. I'm multiplying. Minus 4x equals 8. 2x minus 4x is negative 2x plus 12 equals 8. Subtract 12, you get 8 minus 12 is negative 4. Divide everything by, so I'm subtracting 12, I should say. Subtract 12. Negative 2x equals negative 4. Divide everything by negative 2. X equals 2. How do I get y? Go back into one of these problems, and this will just be really simple if I do this. 2 plus y equals 3. Minus 2, minus 2, y equals 1. Our solution is 2, 1. Again, I'm not checking for the sake of the speed of this video, but you have to check by substituting. So you plug in 2, 1, and I will go over this verbally. 2 plus 1 is 3, so that checks out. 2 times 2 is 4. 4 times 1 is 4. 4 plus 4 is 8. That checks out as well. Okay, y equals 1/2 x plus 1. Y also equals negative 1/2 x plus 9. So what will that look like here? Y equals all this stuff. So instead of y, I'm going to replace it with all this stuff. So I'll say 1/2 x plus 1 equals negative 1/2 x plus 9. I will leave the rest to you to figure out. This one is exactly the same as number 11. You set them equal to each other because they're both equal to y. But again, I want to focus on showing you guys how to solve for a variable. So here, let's what will be easier here? I think this would be easiest to get y by itself. So I'm going to add y to both sides. So I have 4x equals 4 plus y, and I'm going to subtract 4 to get rid of this. So I have 4x minus 4 equals y. So now that I know that all this equals to y, or is equal to y, then instead of y, I can replace it with 4x minus 4. So I'll say 3x minus 2, coming exactly from this. 3x minus 2 times, but instead of y, I know y is equal to all this. 4x minus 4 equals 3. So you have 3x minus 8x and plus 8. Why did that turn to a plus 8? Negative 2 times positive 4 is negative 8. Negative 2 times negative 4, don't forget this sign, is a positive 8. Equals 3. 3x minus 5x, 3x minus 8x is 5x plus 8 equals 3. You'll subtract 8, you'll get negative 5, you'll divide by 5, and you will get negative 1. And then you plug in negative 1 to either of these to find your y. Let's see here. 4 times, I'm going with the second equation. It's up to you, I don't really care. Or it doesn't matter. So you have 4 times negative 1. Let me erase this stuff so I have space to work. 4 times negative 1 is negative 4 minus y. You will add 4 to both sides. And then you'll divide by negative 1. So my solution is negative 1, negative 8. Again, I'm leaving this up to you to check. I'm gonna do one more problem because so far, like, we haven't had to divide by anything to get y by itself. So let's do that. Let's see here. 15 looks pretty complex. So I will get y by itself. Well, the last one I already did y by itself. Let's get x by itself. So I'm actually going to start off by adding 4y. 4y. 3x equals negative 1 plus 4y. I'm going to divide by 3. Negative 1 divided by 3 is negative 1/3 plus 4 over 3y. Again, these are fractions. If you're not good at them, you just got to practice. 5 times negative 1/3. So I found x, and now I can go into the second equation and substitute for x. Negative 1/3 plus 4/3 y plus 2y equals 7. This is going to be hairy. Negative 5/3 plus 5 times 4 is 20. 20/3 y plus 2y equals 7. Oh boy. I'm going to, let's see, negative 5/3. Let's combine these. So 2y is really 6 divided by 3. 6 divided by 3 is 2y. So I'm just going to combine these together to make a bigger... I'm going to combine my like terms. So 26/3 y. And I'm going to add 5/3. So 26 over 3y. So let's see. If I have 7, that is, and my fraction is thirds, that is equal to 21 over 3, because 21 divided by 3 is 7. I also have to add 5/3 to both sides, plus 5/3. 5/3. Pretend I actually wrote that neatly. So 5/3, that's 26/3. 26 over 3 times what is 26 over 3 times 1? Or if it makes you feel better, or if you didn't understand what I just said, you can multiply by the reciprocal, boom. But if you do it on one side, you got to do it to the other side, and you get y equals 26 times 3 divided by 23 times 26 is 1. Next, I'll use the second equation. You can use the first one or the second one. In fact, forget it. I'll use the first one. 3x minus 4 times 1 equals negative 1. So 3x minus 4 equals negative 1. Add 4. Add 4. 3x equals 3. Divide by 3. X equals 1. Whew. 1, 1. Alright, I know these are kind of long, which is why I'm just not going to, and plus you need the challenge anyways. I'm not going to do all these examples, but if you have any questions, ask your teacher, let me know and we'll figure it out. An adult ticket to a museum costs $3 more than a children's ticket, so adult ticket equals 3 more than, so children's ticket plus 3. So this is cost of an adult. This is cost of a child. Adult cost. Child cost. When 200 adults tickets, so 200 times an adult ticket is 200 different, and 100 children's tickets equals 2100. So instead of A, you'll replace it with C plus 3, and then you'll plug it in, you'll get C by itself, and then you'll figure it out. Okay guys, if you don't understand this or anything on this section, make sure you ask your teacher or let me know. And that's how you solve systems of equations by substitution. You find a variable by itself, you plug it in to the other one, or you substitute, and then after you get an x or a y, it doesn't matter which one you get first, you substitute it into one of the original equations. It does not say which one, it just says one of, so it doesn't matter, and you solve. And you double check by substituting your solution into both equations, not just one. So checking requires both equations to be valid with the solution, not just one equation. Alright guys,